Bismillah ar-Rahman ar-Rahim. So we started to talk about GSM. We talked about the general characteristics of GSM, including the international roaming and handover and so on. And we talked about the fundamental services of GSM, including the bearer services, the telematic services, and the supplementary services. Today, inshallah, we need to cover the architecture of GSM. Starting from now, you will see lots of details, new terminology, and things like that. So you need to be aware of this terminology, and you need to be careful not to get confused between the different terminologies. So in this architecture, we have components and we have subsystem, and it's a nice way to actually describe any architecture that you work on for a project or for designing a system and so on. So try to follow this strategy: is to really divide your system into smaller subsystems, and each subsystem into components, and then define the interfaces between the different components or different parts of the system. So that's how they define the architecture for GSM. So in terms of components, we have the mobile station. We talked about the mobile station before. The mobile station including the mobile terminal and the terminal equipment. And we have the base station, which constitutes the big tower. And we have the mobile switching center. We'll talk about that, which is like sort of the brain of the system. And we have the location register, which is actually divided into multiple databases. We'll talk about each database and what is the purpose of this database. In terms of a subsystem, we have three major subsystems. The architecture is divided into three major subsystems. The first subsystem, which is the radio subsystem, which is composed of all the radio aspects, including the mobile station and the base station transceiver and the base station controller, as we will see. And we have the network and switching subsystem, which is composed of this mobile switching center and the location registers. And we have the operation subsystem, which is responsible for monitoring the traffic policies inside the network, performing authentication for the mobile stations, and protecting the mobile stations from being stolen, like generating whitelists, blacklists, and so on, as we will see. So these are the main subsystems and the major components. So this is how the architecture looks like. So we have this subsystem, or the radio subsystem. The radio subsystem is composed of, again, the mobile station and the base transceiver station. Base transceiver station is the base station, is the tower itself. So the base station is connected with multiple mobile stations through what we call interface. We talked about the interface, which actually implements the bearer services in terms of data service. So the base station transceiver with multiple mobile stations form what we call a cell, right? The cell is one base station with multiple mobile stations in a geographical proximity, or in a geographical area, small geographical area. From one cell to another, we use special diversity, right? We use the special diversity, which means that we can facilitate mitigate the interference between those two cells through space diversity or through frequency assignment of the channels. So we need to have like some separation between the frequency assigned between these cells. The one or more of these cells are controlled by what we call the base station controller. The base station controller is connected to multiple cells, one or more cells, okay? Through what we call A-base interface. The A-base interface multiplexes multiple interfaces into a higher level of data transmission bitrate. Like it goes from 16, I think, to 64 kilobits per second. Okay, so the base station controller is responsible for assigning the frequency channels to each of these cells in such a way that it addresses the interference or mitigates the interference. And also, it can facilitate the handover between, for the mobile stations from one cell to another. So when a mobile station moves from the proximity of one base station transceiver to another, then the base station controller is the one that decides when this mobile station can be moved from one cell to another, and then manages the handover, which means that all the resources assigned to this mobile station within this cell will have to be dismantled and then moved to the other cell. So who controls that? Who manages that process? The mobile station controller. And we will talk about different levels of handover later on. There is the intra-cell handover, there is the inter-cell handover, and there is intra-BSC handover, and so on. There are multiple levels of handover that we will talk about later. So all these three components, the mobile station, base transceiver station, and the base station controller, constitute what we call the radio subsystem. Okay, so that's the subsystem where you have radio, you have wireless link, in which case you have to handle some radio aspects, including frequency, including sometimes measuring the delay, measuring the propagation delay, measuring the frequency, measuring the interference at each frequency range, and so on. So this subsystem handles all the radio-related issues. The network subsystem here is sort of the brain. Of course, here it's mostly wired. خلاص يعني احنا we have gone from the radio subsystem into the network subsystem, which is the core network, and this core network is wired. So here we have the mobile switching center, which manages all the base station controllers within a location area. And generally speaking, each service provider will have multiple of these mobile switching centers. Each mobile switching center covers a location area. And a location area is like a sort of a city. Okay? Like مثلا here in Doha, we may have one or two mobile switching centers. And maybe in another city, we have another mobile switching center, and so on. So a service provider will manage multiple of these mobile switching centers. Each one covers a big location area. And a big location area is covered by multiple cells. Each one or two or three cells are covered by one base station controller. مفهوم كده? So that's the hierarchy. That's how it goes. Okay? So the mobile switching center handles all the radio resource management from a high level, okay? And part of it is also to handle the handover of the mobile stations, but this type of handover, sometimes it goes from one location to another. Like for example, if I am driving my car and I'm moving across the city, then I move from one cell to another, right? Which means that my movement is within the domain of one base station controller. So in that case, the base station controller will handle the handover between the different cells while I'm driving. If I drive from one city to another, okay, then I go outside of the domain of one BSC, in which case I have to have like the MSC being engaged or to manage the handover for a mobile station from one location area to another, because I'm moving across cities, right? So that's one major function for the mobile switching center. Another major function for the mobile switching center is to facilitate the interconnection with the other types of networks. Okay, so here we have the the cellular network, and this cellular network may be connected with another type of network like the public switch telephone network or ISDN or ATM or any other type of network, in which case we go through what we call the gateway MSC or the gateway mobile switching center, which is sort of the door outside from the cellular network to another type of network like BSTN or any other type of network. Meshi, so far so good? Okay, so the mobile switching center also, as we said, it's like the brain of the system, but the brain for one location area. And in some cases, it actually interconnects with the other MSC in other location areas. And all these MSCs are usually connected with multiple databases. We call them location registers. So the location registers, we have two types of location registers. We have the home location register and we have the visitor location register. Home location register is a centralized database, if you will. Okay? So this is the one that has all the information about all the subscribers. Okay? So it's a centralized database. And it contains a semi-permanent information. Yani most of the information in the home location register are permanent. Like for example, all the phone numbers of all the subscribers and what type of service each subscriber has. What type of service, the plan includes what and what is the speed and so on. In some cases, it includes all the keys for key management and so on. Okay? And small part of it is also dynamic information. Like, for example, where that subscriber is at this point in time. Okay? In which location area. Because you move from one location area to another. So also when you move from one location area to another, also it gets stored in the home location register. Where are you? Which location area that you are in at this point in time. Based on that, you have the visitor location register. Visitor location register, it's like a cache, okay, which is assigned to one location area. So unlike the home location register, which is like a centralized database, visitor location register is assigned to each location area, which means that each MSC, as you can see here, each MSC is attached with one visitor location register. But all of them sort of share one home location register, okay? So home location register is sort of a centralized database. You may have one or two, but they are in nature centralized because they host most of the general information about the subscribers, including all the services that they have and so on. And then visitor location register contains all the information related to where they are now. Okay, in which location area. And basically when you move from one location area to another, you get assigned like temporary IDs during the time that you are in this location area. So all these temporary information gets stored into the visitor location register. So the way it goes is that in order for me to try to find where you are, okay, so the first thing I should do is to go to the home location register to make sure that you are a valid subscriber, check all your services that you have, and then get the location register of where you are now. Then, based on your location register, then I fetch some cache information from the visitor location register of this location area. مفهوم كده? So first, I go to the centralized database, and then based on that, I know which location area you are in. Based on that, I go to the visitor location register of this location area to get more further information about some caching information of for this subscriber in this location area in particular. Okay? So one very important thing is the interfaces So each of these interfaces, they get defined in the standard documents, like hundreds of pages. So each of these interfaces define certain signaling between these entities. Like, for example, the ABIS interface. This ABIS interface, as we said, multiplexes multiple UM interfaces into high-speed data service of, it can reach up to 64 kilobits per second, which is, of course, very low compared to what we have today. And then it defines certain signaling between the base transceiver station and the base station controller. Some signals going back and forth. Each one is like how the signal looks like, the format, and so on. Similarly, from the base station controller to the MSC, we have the A interface. Okay? And also the A interface defines برضو higher speed. It multiplexes multiple ABIS interfaces into the A interface, so it's higher speed in terms of data rates, and it uses pulse code modulation for the physical layer. And again, it defines set of signaling between the base station controller and the MSC. Okay, between the MSC and the visitor location, it's like direct connection, so there's no need for an interface. But between the network subsystem and the operation subsystem, we have another type of interface called the O interface. And the O interface defines, again, another interface using a standard called X25. X25 is one of the common standards for interfaces when it comes to network management. So this X25 interface acts like an interface between the network subsystem and the operation subsystem. So we talked about home location register, we talked about visitor location register, we talked about the gateway MSC, which is again the output door to different types of networks, whether it's PSTN and so on. And and we have the operation subsystem. The operation subsystem is responsible for two major things: monitoring the traffic policies within the network, and billing, which includes billing. So if you get certain مثلا data rates, you get this amount of money per data rates that you download or upload or something like this. And also when it comes to security, it performs the authentication and it manages the encryption and decryption in terms of key management within the network. Okay, and of course, as part of security as well, we handle the protection of these mobile stations. So if some of these mobile stations they get stolen, we have to store like this is a black list and this is a white list. So this is this mobile station has been stolen, so it gets put in like a black list. So when this mobile station tries to get into the network, it gets of course denied in terms of access to the network. And if it's in the white list, this means that it can access the network as usual. طبعا, this is the general definition of the architecture. We'll get into the details of this in the following slides. So again, this figure here shows the radio subsystem. So this is the radio subsystem, and this is the network subsystem and the connection between them. So this is the A interface. Okay, so this is the A interface. Within the radio subsystem, we have the mobile station. Multiple mobile stations are connected to the base transceiver station, which is the tower, and multiple of these base transceiver stations are connected to the base station controller. Of course, you will have to practice the terminology carefully and try to. Some people they shy away from saying memorize. No. You have to memorize this terminology. They don't like to say it, but so because these things are important really, because some of these terminology have been leveraged in later standards, and it's actually very important for you to, when you hear a certain terminology, you know what we're talking about. We know where we are talking about, where in the system we are talking about. So these are the components, which we talked about the functionality of each one of them, and these are the interfaces. And from one interface to another, when we go higher in the hierarchy, as we go higher in the hierarchy, as you notice, the data rates, they get increased because you multiplex multiple of these data services into one big data service. So for example, the UM interface, as we talked about before, it's like 9.6 kilobits per second. The ABIS interface goes from 16 to all the way to 64 kilobits per second. And A interface, it goes from 64 and above. And in the textbooks, they mentioned that this A interface can get up to maybe 2 megabits per second. But again, all these data rates are very, very much low compared to what we have nowadays. So from the network subsystem, we have two different interfaces. We have the interface to the outside networks, and we have the interface to the operation subsystem. Here we show the interface to the outside networks, as we said before, through an interface called SS7. And SS7 is like an application level interface which we can use to fetch information from the home location register or from the visitor location register. Through the gateway MSC, the Gateway Mobile Switching Center, we can connect to standard networks like ISDN and PSTN. And GSM deals with these networks as sort of native types of networks. These are the typical core networks that GSM uses. So the connection to these types of networks happen natively through the gateway. They don't need any intermediate components. Whereas some other types of networks, like the public data networks, different types of public data networks, whether it's packet switch networks or 6 switch networks, we use what we call interworking function component, which defines specific connection to other types of networks other than ISDN and PSTN. Again, those are defined as compliant types of networks to GSM, if you will. So other types of networks, we have to connect to the interworking function to get to them. ماشي؟ طيب, so this is the radio subsystem, which comprises the cellular and the mobile part. The components are the basic switching, the basic station subsystem, which is composed of the base transceiver station and the base station controller. And the base station controller, as we said before, controls multiple base transceiver station or multiple cells. So, so the base station subsystem is part of the radio subsystem, okay, which is composed of one BSC, one base station controller, and one or more base transceiver stations. Base station transceiver and multiple cells. Okay? And of course, multiple PSCs together, they form a radio subsystem. ماشي؟ IWF اللي هو اسمها interworking function. The interconnection between them the interconnection between them اللي هو الانترفيس اللي هو الUM interface and the ABIS interface طيب طبعا, as we said before, the cell structure, we usually or theoretically define the cell shape as hexagon, even though it's not طبعا practical, but this is just to simplify the shape of the cell. And each cell uses different carrier frequencies, such that the cells that are adjacent to each other, they have to use different frequency so that you minimize the interference between the cells. And depending on what type of antenna you're using, you may actually, inside each cell, you may subdivide the cell into sectors. As we talked before, you can use sectorized antenna, in which case you can have the cell like this. So you can use actually directional antenna or a circular antenna to divide the cell even further into different sectors. Based on that, of course, it affects the frequency assignment. So the cell sizes, in terms of range, okay, vary from 100 meters all the way to 35 kilometers. Okay, so depending on, of course, the type of area that we're talking about, whether it's a remote village or it's an urban city or something like that. And how can we get this range? We get this range by using special types of antenna with different transmission power. So by increasing the transmission power, we increase the range. Okay? But of course, if you do that in an urban city where you have small cells, of course, there will be some interference between the different cells, in which case the transmission power will be reduced so that you have smaller cells. And of course, we talked about the advantage of smaller cells because it increases the capacity of the system overall, right? But if you are in a remote village, you can use big towers, you can use big transmission power, in which case the cell range becomes really, really big, and the user density becomes small. Okay, so the range can be from 100 meters all the way to 35 kilometers, depending on the user density and the type of environment we're talking about. If a mobile user, of course, changes the cell, we have handover, and we have different types of levels of handover that we will talk about. So here, for example, you can, so as we said before, you can use here F1 and F2 and F3, and here you can use F1 again, because the distance here between this and this is too far. So there will be no interference effect anyway. So you can reuse these frequencies. When I say F1 and F2, this can be this can be multiple channels, and as we will see later, GSM uses 124 channels, and these channels can be divided, and usually it's divided in an order of 10 channels per cell. So each cell gets assigned around 10 of these channels, and some channels are used for control information, not used for data transfer at all. Okay, but in any case, these channels are used in an order of 10, but the same channels can be used again for cells that are far or in a minute. Of course, in the base station subsystem, which is composed of one BSC and one base station tower, we have multiple functions, and these functions are performed by either the base transceiver station or the base station controller, or sometimes by both. Okay, so for example, the managing the radio channels, which means that you need to assign certain frequency to each cell. And as you said, in terms of frequency assignment, what happens is that you have like cell 1 to be assigned F1, and cell 2 to be assigned F2, and so on, cell 3 to be assigned F3, and so on. And then you can reuse the same frequency for cells that are far, in which case you use special diversity. So if the distance between the cells is too far, this means that there will be no interference effect, in which case you can reuse the same frequency again. So separated in terms of distance between each other. So in terms of managing the radio channels, this is done by the base station controller. In terms of frequency hopping, this is usually managed by both. يعني frequency hopping. يعني frequency hopping? This means that within the same cell, the cell itself jumps from one frequency to another. Why? Why? Because as we said, noise is frequency selective. The noise itself is frequency selective, which means that the amount of noise that you get in a certain frequency range is usually different from one frequency to another, right? So if I assign one frequency to one cell all the time, this will not be fair, because depending on the frequency range that this cell has, maybe it will be at a disadvantage because the noise within this frequency range is high, right? So in order to make it fair, we need to jump from one frequency to another. And usually, you can change this per one super frame, as we will see, because you have like TDMA, you have like a super frame where you assign time slots, big super frame, which is like 8 different time slots. And after each super frame, you can in fact jump from one frequency to another. So you can jump within around 5 milliseconds. Every 5 milliseconds, you can jump from one frequency to another. So this frequency hopping is actually managed by both the base transceiver station and the base station controller. Okay? So the base station controller manages how one cell can jump from one frequency to another, but then coordinating these frequency jumps so that there is no collision between the frequencies is done by the base station controller. So it's like the frequency hopping has to be done on 2 levels, and that's why it needs to be managed by both the base transceiver station and the base station controller. أيوه. أنا مستني أسئلة من زمان، عايز أعرف، حاسس كده الناس يعني interacting. أيوه. لا بالعكس، احنا بنقول we have a super frame. A super frame is like multiple time slots. Okay? Multiple time slots, as we will see later, we have around 8 time slots. The super frame is composed of 8 time slots, and this super frame is less than 5 milliseconds. It's divided into 8 times. So one time slot is around 0.5 millisecond. Exactly, it's 577 microseconds, something like that.
So frequency in
لا. After the whole super frame, after 5 milliseconds almost, plus or minus, then you can jump. After the entire super frame, not per slot. لا. After 5 milliseconds, then you can jump. But this jumping again is important to create some kind of fairness for the effect of the noise, right? Because when you move from one frequency to another, then it's fair because the effect of the noise is different from one frequency to another. So when you switch through all the different frequencies, this way you get to taste all types of noise in each range. So this way, it's fair. Okay? Otherwise, you will see like the performance for one cell very bad, and the performance for another cell is very good, and so on. So this cannot happen. Of course, managing the data services is done by data services or terrestrial channels. Terrestrial channels اللي هي الABIS interface and اللي هي data services اللي بتمultiplex multiple UM interface. And this is of course done by the base station controller. And of course, mapping the different radio channels to the different terrestrial channels. Channel coding and decoding. Channel coding and decoding is a physical layer issue for the radio, and it's done by the base transceiver station. Rate adaptation here is between the mobile station and the base transceiver station, and it's managed by the base transceiver station. Also, encryption and decryption. When it comes to security, you will find that it's implemented in all the components, not just in base transceiver station and the base station controller is actually, so the MSC has برضو part of managing the encryption and decryption in terms of key and authentication, and even the operation subsystem, as we will see. So when it comes to encryption, decryption, or security issues, you will find that most of the components are there. Because again, security is one of the issues that it needs to be handled in all layers. تمام؟ it's very common and very important that it has to be handled in all components. Paging. Paging is used to find a mobile station. يعني when you try to call someone, what happens is that I need to search where this mobile station is, right? So when someone, and I'm connected now to Ooredoo, right? So someone tries to call me. So the cellular system needs to find where I am. So it uses the concept of paging. And usually paging is done hierarchical. So it goes from the home, we will see the sequence of paging in details later on. So usually it goes to the home location register to know which location area I am in now. And then it goes to the visitor location register to get the information, the detailed information of me within this location area. And then from this location area, it has to send some paging signal to the mobile switching center of this location area to ask this mobile switching center to find me in this location area. And then mobile switching center will send this paging signal to all the base station controller in this location area. It's in a broadcast. And then each base station controller will send a broadcast paging signal to all the cells until they find where I am. So really, paging here happens in a broadcast way, but broadcast within one location area. Which location area? Based on the home location register. So they know the location area of where I am, and then they assign this job of finding me to this mobile switching center, which is responsible for this location area. From then, it sends a paging information or a paging signal, which gets propagated from this MSC to all the BSCs, from the BSC to all the base transceiver stations, and from all the base station transceivers to all the mobile stations within this cell, until one mobile station says, I am the one whom you are looking for, and then it sends a response back, and this way they can find me.
I still didn't get why we need visiting log register, because like in the home log register,
It's
the location, the current location of the user is the same, right? And in the visiting log register,
لا هو الموضوع very detailed. يعني هو when we talk about the different identifiers, for a subscriber or a person or a mobile station. One mobile station would have almost around maybe 10 different identifiers. There is an identifier to the mobile station itself as a device. There is a serial number for this device. And there is an identifier for the SIM card. And there is a phone number. And there is a PIN number. And there is some of this information.
this is permanent information.
Yes. Some of this information are sort of confidential. Instead of exchanging this information on a public channels, they use temporary identifiers. That's what I was getting at. Okay, so to avoid sending مثلا PIN numbers ولا حاجات زي كده on public data channels, they use temporary identifiers. These temporary identifiers, they get cached into the VLR, and they are temporary because they are valid within this location area. When you move from one location area to another, they change to another VLR. The VLR, what it does is that it fetches some information from the home location register. Okay? Whenever you go to this location area, the VLR of this location area fetches some semi-permanent information from the home location area, and it adds to it some temporary identifiers during the time that you are in this location area. So that's why I said that the VLR, you can think of it as a cache version of the information in the HLR, along with some extra information that gets generated temporary while you are in this location area. And then when you move to another location area, this information gets regenerated in another VLR and so on. Okay? There is an uplink signal measurements, and these signal measurements are very important for handover. So the mobile stations, when do I decide that this mobile station needs to perform handover from one cell to another? So this uplink signal measurement, معناها إيه? The base transceiver station needs to measure the round trip time of information for every single mobile station in the cell. Based on that, it says that based on this measurement, the performance of data transmission to this mobile station is very bad. So I cannot continue anymore sending information to this mobile station, and this mobile station needs to perform a handover or something like this. So this measurement, which is what we have called it before, channel state information. So this measurement is part of channel state information, which is very important for me for radio resource management and for handover. واضح? So of course this is done by the base transceiver station. In terms of traffic measurement or traffic monitoring, authentication, location registry, and all these are all a high-level functionality which is done by the base station controller. Yeah, hey.
No, this is encryption and authentication.
Yeah, authentication is done by the authentication in terms of the algorithm. The authentication معناها ان انت you exchange the keys and then someone runs the algorithm to verify whether you are authenticated or not. So in terms of running the algorithm itself, it runs in the BSC. ماشي؟ طيب. So we have the mobile station. The mobile station, we have divided it into two parts. Now it's subdivided into further divided into three parts. We call this the terminal adapter, which is sort of an interface which hides all the radio aspects in this mobile terminal from the application level services. As we have mentioned before, the mobile terminal here performs all the radio related functionality up to the network layer, whereas the terminal equipment performs the application level services. Application level services, like for example, sending an SMS, group fax, things like that. So these are the application level services. Mobile terminals, it deals with radio aspects. So it deals with all the physical layer, link control in terms of flow control, reliable transmission, and so on. So this is done here. So the terminal adapter, it's like an adaptation between the application level services and the mobile terminal. Okay. So that's so of course here this is the interface, which is used to communicate with the base transceiver station. So this is the subcomponents inside the mobile station or the mobile terminal. The network and switching subsystem, which is composed of the MSC together with the location registers. So we have the MSC, which is, as I said before, it's like the brain or the heart of performing most of the high-level functionality within one location area. Within one location area, okay? Which means that one service provider will have multiple of these MSCs, okay? So the MSC is responsible for connecting this cellular network with other types of networks like PSTN or ISDN or something like that. And also it's used to manage the handover between the different base station subsystems, or BSSs. And it also uses the home location register, which is, as we said, the home location register, it's a central master database containing user data, including services and so on. Most of it is permanent, but some of it is also dynamic, which means that when the user moves from one location area to another, at least I need to store the new location area into the centralized database, right? And then there is some detailed information for the subscriber within this location area, which is then stored in the visitor location register. So the visitor location register, it's a local database, which means local يعني within one location area. Okay? And it stores data, including data about all the users currently in the domain of this location area. And we will see the different types of information within the visitor location register. So the MSC performs all this functionality, performs the switching functions, performs the mobility support. So when you move from one base station subsystem to another within the location area, or you move from one location area to another. And it performs the network management functions, or in terms of radio resource management. And it performs the interworking with other networks, okay, through the gateway MSC or through the interworking function. And it's used to integrate with different types of database, including HLR and VLR. So specifically, the MSC is used for paging and call forwarding. And as we said before, paging is used for to identify or to find where I am, and it connects me with the other party that is trying to call me. It uses a protocol, application level protocol, or a signaling protocol called SS7 to interface with the different databases, the HLR and VLR. Mobility specific signaling for handling the handover. Location registration and forwarding of location information. So when I move from one location to another, I need to forward the information. I need to migrate the information of this subscriber from one VLR to another, right? So the temporary information needs to migrate with me. And some permanent information is still in the HLR, but there is some temporary information that migrates with me from one location area to another. Provision of new services like fax and data calls, performs the SMS, generation and forwarding of accounting and billing. So the accounting and billing is managed by the operation subsystem, as we will see. But again, the operation subsystem connects with the MSC to facilitate the billing, right? So this is one of the functions that requires multiple components, similar to security as well, because we will see that operation subsystem is also responsible for security. So when I connect to one mobile station using like some secure communication, first I need to authenticate this mobile station using the operation subsystem through the MSC to the base station controller. So I need to generate one secure communication from the operation system all the way to the mobile station. So this is the operation subsystem. It enables centralized operation and management. So as part of this, you have to maintain the entire network, but in terms of traffic policies, in terms of user billing and so on, authentication. There is something called Equipment Identity Register. This AIR is another type of a database. So we have HLR, we have VLR, and we have EIR. EIR is this third type of a database, which is part of the operation subsystem. But this one has a different responsibility. This one is responsible for creating whitelist and blacklist, basically. okay, which is used to protect the mobile station. So if one mobile station is stolen, okay, so the subscriber will report the fact that the mobile station is stolen, then I put this in blacklist. So whenever a person tries to use this phone and connects to the network, the operation subsystem will find out that this is part of a blacklist, so it will deny the service to this user.
I'm sorry, but what does the subscriber mean? I'm sorry.
A subscriber لو أنا شخص معايا في سيلفون, I am the subscriber. A subscriber, any user with a mobile station. Okay. So there is okay.
Regarding the authentication, it's like user data on the air interface within the GSM system.
Tani?
Air interface within the GSM system. So there's air interface authentication.
Yes.
Between the mobile station
and the base transceiver station. Yes.
The table before it was the authentication only in the base station.
لا ما قلناش كده, تعال نشوف. طيب الاوبريشن اند مينتنس سنتر بقى, it performs different control capabilities for traffic monitoring with status report in terms of network management issues, يعني اللي هو بقى الترافيك policies والاشياء ديت يعني. والsecurity management in terms of the key management. So each subscriber will have different types of keys. We'll talk about that maybe later. Different types of keys. So these keys are used for authentication, for encryption, decryption, and so on. So all these keys are hosted within the operation subsystem, and then it gets managed by the operation and maintenance center. And of course, in addition to the accounting and billing. طيب, we talked about this before, the GSM. So as we have discussed before, for GSM defines 124 channels uplink and 124 channels downlink, and it uses FDD. So you have 124 channels for downlink, starting from frequency 935 megahertz all the way to 900. So this is the GSM 900. GSM 900, which means that the carrier frequency for GSM is 900 megahertz. Okay. Of course, there is GSM اللي هو 1800, and there are other versions, but here we're talking about the 900 version. So for GSM 900, we have 124 channels downlink and 124 channels uplink, and we use FDD. FDD معناها ايه؟ ان الuplink and the downlink are separated in frequency, and there is like some guard band between them. So each channel is further divided into time slots. So as we discussed before, in GSM we use a TDMA, FDMA, right? We use a combined TDMA, FDMA, which means that we combine the spectrum into channels, and then we divide each channel into time slots. So each channel is divided into time slots, and this is what we call a super frame. This is what we call the super frame. The super frame is around 4.615 milliseconds. Okay? So after each super frame, which means one channel, I can hop. مفهوم? So after each super frame, I can hop. So after 8 time slots, I can hop. Each cell gets assigned, on the average, around 10 of these channels. Okay? And some of these channels, they get assigned for control, not for data, actually. So not all the 124 channels are used for data transfer. Not all of them. Some of them are assigned for control signals. Around maybe 90 of these channels, they get assigned for data transmission, and each cell will get assigned on the average around 10 channels for data transmission. Which means that on the average, each cell can accommodate around, so you have here 8 time slots. If each time slot is assigned to one user, okay, and you have 10 channels per cell on the average, which means that each cell can accommodate up to how many users?
No, sir, confused. 1 second, sir. One channel means 124 channels. And each
لا
channel,
يعني one channel.
no, one 900 to 890 to 915 megahertz. There are
124 channels, yes. These are divided into 120. Each one is 200 kilohertz. Yes, you are.
So
Yeah.
200 kilohertz multiplied by 124. So this
Right,
band
right.
is coming.
True. Yes.
Now this GSM TDMA frame. This frame is for this 25 megahertz width.
This is, yes, this is for the 200 megahertz. This channel is 200 megahertz, 200 kilohertz, sorry. This channel is 200 kilohertz. Within this channel, you divide it into 8 time slots. Okay? If we assume that each time slot is assigned to one user, okay? And each cell gets assigned 10 of these channels, because not all these channels can be assigned to one cell, right? Because if all these channels get assigned to every cell, this means that we will have interference. صح? So each cell gets assigned around 10 data channels, right? متابعين ولا؟ We have 124 channels, right? Remove around 34 of these channels for control. You have around 90 channels for data, right? These 90 channels for data, they get allocated to the different cells. We cannot allocate all the 90 channels to all the cells, otherwise we will have interference, right? So we assign each cell, on the average, around 10 of these channels. So each cell gets assigned 10 channels. Each channel is divided into 8 time slots. Huh? And a user gets 1 time slot here, okay, in one channel. This means that one cell can accommodate up to how many users? Huh? 80 users. So you have 8 users per channel, per cell, and each cell might get assigned around 10 of these channels, which means that 8 times 10 is around 80 users, right? Plus or minus, but. Because a cell may get assigned more than 10 channels, and maybe one user can get assigned 2 time slots. This is left flexible. This is based on the radio resource management, which is done by the MSC and by the base station controller. The radio resource management is done by these two components. So they may decide to give one mobile station 2 time slots. They may decide to give one cell more than 10 data channels, plus or minus 11, 9, something like that. All right? On that, you seem confused.
You said we have 90 channels.
90 channels for data, yes. Around 34 channels. Those are for control information.
10
Control
channels for
signals.
each cell.
Yeah, average, plus or minus.
Why? How many cells? How
Hmm?
many cells? Why it's around?
We have many cells. ما عشان كده أنا بقول on the average around 10, maybe more, maybe less. يعني maybe more, maybe less, depending on the environment, depending on the spatial diversity that you have. Okay, so you have 90 channels. You allocate them in the same مثلا location area أو كده. يعني بعد كده in other location areas the distance is too far, so you can reuse the same channels. You can reuse the same channels again, right? So the allocation is not fixed. That's why I'm saying everything is like average, plus or minus. I cannot just tell you it's 10, it's kaza. So But the eight slots per channel, this is fixed. Yeah, this is fixed. So, for example, if you want to accommodate more users, then you can give more channels to this cell. But each channel is divided into 8 time slots. This is fixed, which means that one super frame is 8 time slots. And it's fixed in terms of time. It takes 4.615 millisecond. This is fixed.
The super frame can save like 10 users?
8 up to 8 لأن هو ممكن
Time slot, no? GSM time slot.
ده
Yes?
this is one slot. This is not the super frame. This is the frame format for one slot. Yeah, this is to be used by one mobile station. And maybe one mobile station can use maybe 2 of these time slots, depending on radio resource management. Radio resource management may decide to allocate 1 or 2 time slots to one mobile station, right? That's why we need to have like some constant measurement for channel state information, and then based on the channel state information, we assign the frames or the time slots to different users. Any other questions? طيب, when we zoom in one time slot, we find that this is the format of one time slot, which means that this is the frame format, which is going to be used by one mobile station. Of course, as we talked about before, in TDMA, we need to have guard bands. Guard bands in TDMA accommodates or accounts for propagation delay and to facilitate the fact that there will be no overlap between the time slots, right? So, of course, depending on whether the mobile station is far from the base station or close to the base station, the propagation delay may be more or less or something like this. So I need to have like some guard space to make sure that there will be no overlap between the time slots. So if I take away the time slots, the guard space, I will end up with around 500 microsecond for the frame. Okay, so the frame format itself is divided into, we have a tail on either side. This tail is used to mitigate the synchronization. Again, remember we talked about the fact that whenever you have multiple nodes trying to agree on a specific start and end for the time slot, we have the issue of synchronization, right? Why am I seeing like pale faces? Synchronization. Resolve, يعني try to mitigate, try to address the issue of synchronization. Try to address the issue of synchronization. Why? Because when the time slots start and end at specific time, this specific time is calculated based on the clock of this node, right? But if you have multiple nodes, you always have like some difference in the clock, right? So even our clocks will have some time difference, right? So we need to synchronize. We need to have a specific start and a specific end for the time slots. How can we do that while we have different mobile stations with different clocks, right? How can we do this? So to address the synchronization issue, we have redundant bits that we put into the frame which will help. So whenever any mobile station sends data, right, all the other mobile stations in the area, they will listen to it, right? Because it's radio, it's wireless. So they will take these tail bits and they try to use it to synchronize with this mobile station. Okay? So these tail bits, they mark the start and the end of these time slots. Mobile stations will use these tail bits. It's redundant bits. It's not part of the data. right? So I send it at the beginning and at the end to mark the beginning and the end of the time slot. ليه؟ عشان each mobile station will take these. Usually these tail bits they will have changes in the signal, and these changes in the signal they are used for the clock to adjust. So it's like I'm sending my clock as part of the data for other mobile stations to synchronize with me. Right? So this is one of the very common techniques for facilitating the synchronization, is to send some redundant bits, which we can use for self-synchronization, or to address the issue of synchronization, right? Because we always have some clock drift between these mobile stations. So to allow these mobile stations to agree on a specific clock, we either we force all the mobile stations to take their time from a centralized entity, or we can do it in a distributed way using some redundant bits that we send before and after the data. Okay? So these tail, so عرفنا دلوقتي guard spaces are used to for avoiding the overlap between the time slots, to account for propagation delay. Tail bits are used to facilitate the synchronization. And then I have two, actually the tail with the training bits are used also for synchronization. Now you have two parts of the user data. These user data parts, you have them separate because any one of them can indicate either actual user data or control information, which is indicated by this signal indicator. So this signal indicator indicates whether this user data contains actual data or control information. Okay? So this format constitutes one frame which is used by one mobile station. Okay? Which is divided into tail, user data, and a signal indicator, and the training bits. ففهمنا يبقى you have uplink and downlink, each one 124 channels. We use FDD. Okay? And then each channel is divided into 8 time slots. Each time slot is divided into frame format, which has some 2 guard bands, 2 tail set of bits, training sequence in the middle, and 2 parts of either data or control information. They call it signal indicator. It's like a flag. It's like a flag. A flag, if it's 1, this means that it's a user data. If it's 0, this means that it's a control information. And you can have one of them user data and the other one is control information. Depending on the standards, it defines, you have some flexibility to actually define here user data and here control information, or both of them control information, or both of them user data. It's up to you.
About the training, it's 26 bits only for synchronization?
Yeah, it's for synchronization. It's for synchronization, and it's used as part of channel coding or something like this as well. يعني, there is another function of this training which I can't remember at the moment. It's not only used for synchronization; it's used for other things. It's used for one extra function which I can't remember.
It's like as divided in that.
It's probably like this, yes. طيب. So this is the layer stack. So this is of course the mobile station, and this is the base transceiver station, and this is the base station controller, and this is the mobile switching center. So as you can notice, the mobile station and the mobile switching center, they contain all the stack from the physical layer all the way to the application layer. So for mobility management and call management, this is like a higher layer functions which facilitates the handover and facilitates also the call management in terms of sending the paging signal and so on and so forth. And this, these two layers are contained only in the mobile station and the mobile switching center. So it goes from the mobile station to PTS, to BSC, and to MSC. These three layers, they constitute the physical layer, data link layer, and routing layer, or network layer. This is radio resource layer, and in the radio resource layer we perform the radio resource management and so on. This is like the link adaptation, which is used for as a data link layer. So it performs two functionality basically: reliable transmission and flow control. So this one is used as for the interface. That's why it's called LAPDM, which refers to the interface, and it performs the reliability and flow control as part of the data link layer.
So I think assign for each user have each
specific بقى يعني rate adaptation as part of rate adaptation, flow control, link control, establishing one data session and so on, which is يعني the standard function of data link layer functionality. طبعا radio here is the physical layer, which performs بقى channel coding, modulation, and so on. Okay. The same layers here correspond to the base transceiver station. Here, as we said, for the base station controller communicates with the MSC for the SS7, and here we have the physical layer is slightly different between those two. The physical layer here uses like a primitive physical layer اللي بيسموها pulse code modulation. Pulse code modulation is a primitive physical layer technique which uses samples the signal and then sends the signal as a digital signal over the wired medium. So as we talked about before, from BSC to the core network, it's wired. So we use pulse-coded modulation as a primitive physical layer to convert any analog signal into digital signal and then transmit it over the wired networks. So there's no specific techniques that we use for physical layer, and we don't need to make it very complicated like here. Here, it has to be a little bit more complicated because we have to use digital modulation and so on, because this is a radio layer or radio link. Now for wired, we use a primitive type of physical layer. طبعا هنا at each stage here we show the interface between the different subsystems. طيب here بقى the sequence for paging. So this scenario talks about the fact that from a public switch telephone network, يعني basically a landline, someone tries to use a landline to call my phone. Okay? So what are the steps to be done to find my mobile station in a cellular network as part of GSM? Okay? So someone from a PSTN tries to initiate a call to a GSM subscriber. So what will happen is that first, as we said, the cellular network is connected to PSTN through the gateway mobile switching center, right? So first, the call, this call will go through the gateway mobile switching center, and it goes to the HLR, Because the HLR, so the first thing is that it goes to the HLR. Why? Because the HLR is a centralized database, again, different from what we have discussed. The HLR is a centralized database which has all the information about me, including the location area of where I am now. Okay? So when it goes to the HLR, which is number 3 here, then we request what we call the mobile station roaming number from the VLR, which possibly refers to what you were talking about. So we fetch what we call the mobile station roaming number from the VLR, which refers to, from the HLR, I know where the location area of this mobile station. Then I go to the VLR of that of this location area to get the information about this subscriber in this location area, right? Which is number 4, right? Then this call will go back to the HLR with the information about this mobile station. Then the HLR will forward this call to the mobile switching center of this location area to take an action regarding finding me in this location area. So the mobile switching center, will need to send a paging signal to all the BSCs and to all the cells to try to find me. So from this mobile switch center, it's broadcast paging to all the cells. But before it does that, it needs to send to the VLR to get the status of my mobile station in this location area, whether I'm actually a valid subscriber, I have the right to make this call, I have different, مثلا, for example, enough credits and so on and so forth. And then, so this is done as part of 8 and 9. I get the status of this mobile station from the VLR. And then I start the paging. The paging from the MSC is a broadcast signal to all the BSSs, which is I send to all the base station controllers, and then each base station controller will propagate this paging signal to all the base transceiver stations, which means to all the cells. And the base station transceivers will send it to all the mobile stations. So this paging is done in a broadcast fashion. So the only way to find me is through broadcast. Within a location area, you do broadcast. And then the MS will answer. Then I need to, when I answer, I need to establish the communication. As part of establishing the communication, I need to establish secure communication, which means that I need to handle the security issues. And this is part of the 14 and 15. Okay? And then the call gets set up. So that's the sequence of trying to find one mobile station in a cellular network. So we can subdivide it into like 3 different stages. So the first, I try to find a mobile station in a specific location area, which is through the HLR, right? And then the second stage is to try to check the status of this mobile station through the MSC. So the MSC will check the status of, and then stage 3, as an overview, stage 3 is to try to page to find that mobile station. And paging is done in a propagation way, in a broadcast fashion. And then you establish the call, which is like a secure call. ماشي? So these are the major steps. Okay? So
the authentication steps or the encryption.
Yeah, Mahdi, this is
Checks or these
yes, this is part of this.
Because 14 and 15 is between the MSC and the VLR, not between the MSC and the BSC.
And قصدك the operation subsystem and the authentication module and the operation subsystem. Yes, ما هو as part of this actually يعني this might actually go and come back. يعني as part of this you have some steps that are hidden. So there are more steps but they are hidden from here.
After 2 times it is going, from GSMC also it is going to HLR VLR means.
Yeah, so to VLR, there are two major steps. The first one is that you need to check the status of this mobile station. The status, whether this mobile station is subscribed to this service, whether it can actually perform this call, whether it has enough credit to this call, and so on and so forth. Okay? After you do this check, if the answer is that you don't have enough credits or something like this, then I don't need to do any further steps, right? If the answer is that, okay, you are valid, you have everything correct, then you need to do the paging. After you do the paging, you find the MSC. Then you need to perform security checks. And you need to establish a secure communication. As part of establishing secure communication, you also need to connect with the VLR. So 8 and 9 is for checking the status. 14 and 15 is for establishing secure communication. And actually, as I said to Abdul Hadi, as part of 14 and 15, you may actually go to the operation subsystem, because the operation subsystem handles the authentication. Okay? Which is not, it's hidden from here.
Even the EIR?
Even the EIR, yes. When we go to the operation subsystem, you have to check the EIR whether this mobile station is stolen, is in the blacklist, is in the whitelist. All of this is hidden. Yani. Yeah, so there are further steps that are hidden from here. Any other questions? Of course, if it's the other way around, which means that a mobile station is trying to call a landline. In that case, I don't need to page, I don't need to broadcast, because it's the mobile station is the one that's initiating, so it knows its location area. So many of these steps are not needed, right? Because the mobile station knows exactly everything about where it is and so on. So I don't need to propagate any paging. So some of these steps are actually hidden. So of course, you need to do security checks, of course, as part of establishing the call. But in terms of finding or connecting with the HLR to find the location areas, I don't need to do that, because it's the mobile station knows where it is, right? So the connection request gets to from the base station subsystem to the MSC directly, and the MSC will perform the security check or the status and the security check through VLR, and then it establishes the connection directly. I don't need to do any further action in terms of sending paging command or paging signal to all the base station controllers and so on. I don't need to do that, right? So many of these steps are hidden. Okay. طيب. As we said before, there are multiple levels of handover. You are concerned about your presentation, Okay, so we'll talk about this and then we'll stop. So there are 4 types of handover. لا, we'll not delay it, not delay. So there are 4 types of handover. There is an intra-cell handover. Intra-cell handover happens when you do frequency hopping. So when a mobile station within the same cell hands over from one channel to another, that's also considered one level of handover. Because as part of switching from one frequency to another, there is an overhead, right? So you have to switch your transceiver from using one frequency to using another frequency. As part of that, there is some kind of overhead. Of course, it's a low overhead. But as we can imagine, this type of handover is handled by the base transceiver station directly. We don't need the engagement of BSC because it's the handover is within the same cell. We just hand over from one frequency to another. So there is no need of engaging the base station controller.
We need to cooperate with other BTS.
I understand what you mean. So the base station controller assigns that frequency, right? So it goes to the BTS that it needs to use another frequency, right? So now the mobile station needs to perform the handover. The handover in that case is handled by the BTS, خلاص. But of course, this frequency originally came from where? From BSC, right? So, but this is not the handover. The handover happens within this, right?
What is the name of this type?
It's intra-cell handover. All the types are. So this is called intra-cell handover. Okay, intra معناها دايما within, right? So number 2, it's called a inter-cell handover. So for inter-cell handover, I need to hand over from one cell to another, right? Which means that not only do I need to switch the frequency, I need to switch all the resources assigned to me within this PTS to another PTS. So the overhead here is more, right? So in that case, I perform the inter-cell handover, and in that case, I have to engage BSC, right? Assuming that those two cells are controlled by the same BSC, right? So if here I use inter-cell BTS, okay, then I have to engage the BSC, sorry. So the fourth type, this is the enter cell. So I need to move from one cell to another, but those two cells are controlled by different BSC. One cell is controlled by one BSC, and the other cell is controlled by another BSC. So it's enter cell and enter BSC.
Why is connected here with the controller of inter-cell and intra-cell?
فين؟
The controller of the inter-cell.
Yeah, so number 3, I'm moving from here to here such that this one is controlled by this BSC. لأنه مش شايفه طبعا مش عارفين. This one is controlled by this BSC, right? And this one is controlled by this BSC, right? So in that case, I have to engage MSC. So for enter cell, enter BSC, I have to engage MSC. Okay? أيوه.
Third cell.
Third one, yes.
Third one.
Yes.
It's controlled by the first one. Why there's three? Why there's two? Then the other one.
لا ما هو دايما كده MSC to BTS to BSC to MSC لازم. صح؟
أنا شايفاهم كلهم BTS.
حاجات كلها دخلت في بعضها. So yeah. So number 3 is controlled by this BSC, and number 1 is controlled by this BSC. Which means that those two cells are controlled by two different BSC, in which case I have to engage a MSC. Okay? And the fourth one here is a enter MSC. For enter MSC, I have to engage two MSC together. And MSC, you can consider them they are connected using like mesh network or something. They are connected directly. There is no higher level higher than MSC. Okay, so you connect through different MSC. ماشي? So there are 4 types of handovers. Of course, from one handover to another, the overhead is more. كل ما يعني بطلع في higher level of handover, the overhead is more because I have to move the resources, I have to move so many things across all these components. And overhead is more, which means the delay associated to the handover is more. Okay? Here. So we'll talk